solve these questions. Just some definitions that you have to know before we prepare for our exams that we'll be writing this Monday. So probably this is a tutorial that has some questions that came from some past papers, then they just put them in this tutorial. Well, I just thought of solving this because it might come in hand. Okay, so the first question was saying define and discuss the following. So here just required to define and discuss the following: A, B to I. You've been given a hint. Probably this hint won't be there in the exam, but here is a tutorial. You've been given a hint to say you can write a formula, you can write a graph where you can, and you can also give an equation where applicable. It means that you can put any of these. If you've forgotten how the formula for the thing that you want to define is, you just put the graph. If you've forgotten how the graph is, you give an equation. If you can explain it or define it, just do that. Okay, so we start with the first one, A, which is production. So what comes in your head when you hear production? What is production? Okay, so production is simply a process. It is a process where a firm combines all factors of production to produce the outputs. Okay, so we have factors of production, right? We have factors of production. Probably this is not only about micro, it's also about macro. Okay, we have factors of production, which is labor, we have capital, we have land, we also have entrepreneurship. Yeah, so you find that you get wages from here, you get capital from there, which is capital from there, you get natural resources from there, uh, yeah, which are simply natural resources. Example like land, probably like I mentioned at first. And yeah, entrepreneurship is simply the ability for a person to combine all these three in terms of production. If you are able to combine all these three and produce something, then that person is called what? An entrepreneur. Okay, so that is all about production. Without wasting time or making the video long, I'll try by all means to just simplify these definitions so that everyone at least has an idea of what they're supposed to do. Okay, so production is simply a process of just combining these factors of production to produce what? Outputs, or inputs to produce outputs. So that is production. B, so production theory. Production theory is simply a theory that tries to explain how firms try to use these inputs. They buy inputs, and combine those inputs to produce what we call outputs. Okay, so that is producer theory. They will try by all means to buy inputs that cost little costs and maximize profit from those inputs that they've bought. So producer theory is all about these firms trying to maximize their profits by buying or using the lowest cost when it comes to buying or consuming these inputs, and to maximize profit. You know that these firms are there to maximize profits. Any firm that is rational, probably in economics we assume that every person that is doing business is there for profit maximization. If probably I was doing a business that I didn't intend to make profits, then I would be considered to be irrational, because what am I doing there? Okay, so that is how it is. So we've answered this and we've answered that. Okay, let us move to C. What is production function? So a production function is simply a function that is going to show the maximum. So remember that we're getting inputs. We combine these inputs to remove what we call as to produce outputs, right? So this production function will show the maximum outputs that are going to be produced from these inputs that we are combining. Of course, here and there we do not have formulas or equations, So that's the reason I didn't bother putting any equation there. We can just illustrate this part to have, you can say, we have this as a budget constraint. We know that a budget constraint, or sorry, not an ISO cost. So an ISO cost, we know that an ISO cost is going to show the total cost of all the inputs that are on this in difference. I mean, in this ISO quant. Okay, I'm really sorry, guys. It's just that we are used with all these terms, macro, micro, all these things. But otherwise, you just bear with me. Okay, so we know that an ISO cost line is going to show the total cost that this firm, or this person or individual or any person that is trying to produce something has to pay. Okay, if I decided to buy the points from this point here, I'll pay the same cost when I buy inputs at this point. So the inputs that at A and the inputs at B cost the same total cost. Okay, because remember that things that are on the same ISO quant, let me just say inputs on the same ISO quant cost the same cost, and probably they produce the same quantity. Okay, so that is that. So that is about this one, but since we're not talking about that, we won't stick ourselves to that. Okay, so we're going to move on. As I was saying, the production function will show the maximum output that is going to be produced if the function, if we get labor and capital, natural resources and entrepreneurship, we put them together. This will be the maximum output that are going to be produced from the given level of inputs and the available technology. So that technology that is available, that's the technology that is going to determine how much quantity is going to come out from whatever you're producing with the inputs that you have. Mainly, we always use labor and capital. It's not always like that, but that is what mainly we use. We use labor and capital to be the inputs that we mainly know. Okay, so of course I just included this because you have to know that the factors of production are actually 4, not 2. Okay, so that is that. We move on to short run and long run. So what is the short run and what is the long run? So the short run and the long run, these are simply time periods when a firm decides to see how these outputs that are being produced can come out when a firm tries to change this and puts this constant, or change both at the same time, and see how much quantity is going to come out. So in the short run, a firm will have one thing varying, okay, and mainly we know that it is always labor that is going to be varying. Okay, capital will be constant. Houses, the building, all those things, machineries are going to be constant. A firm cannot always buy machines all the time. Okay, so that is why we say these things are going to be constant. And then labor, probably find that of course they can decide to hold capital constant and they add more people to the same labor. They buy 5 shovels. They won't, I mean 5 shovels, yeah? Then they won't continue buying more 5 all the time. No. They might just say, okay, we're going to use these 5 and then we'll continue adding up labor. We'll add 1%, the second person, the third person. As you can see, this is changing, but this is constant. So that is what we're saying. And then in the long run, we have both of them vying. What you mean is both of them are changing. Find that this is changing, the shovels are changing, they add 1, they add 2, even the people are changing. So that is in the long run. Okay, we move on to total product. So total product, from what you think, what is total product? Of course, total product is simply what quantity has been produced. Okay, what quantity has been produced. It is simply comes from the production function. As you can see, a total the what's this the production function is going to show the maximum output that are produced, and total product to also show the maximum output is produced by at a given input. Okay, so we can have, let's say, a table there, right? We have we have labor there, we have capital there, and then let's say we also include total product there, so if we add one labor, sorry, yeah, if we add one labor, we add one capital, what are we going to produce? Let's say 5. Now if we add the same capital, then we add 2 labor, what are we going to produce? Let's say 10. So this change of total products by a given um, input that is there. So if we use this and that, what are we producing? If we use that, what are we producing as the total product? So it is simply going to stand for the maximum output that is produced from the given level of inputs using the available what technology. So total product can simply be explained using the production function. Okay, nothing's complicated there. I believe we can as well try to research more about that. Okay, but that is that. Nothing is complicated there. Okay, so what is average product? So average product is simply the production. Of course, here we can have a formula. So average product is simply, we have total product, right? Per total product, per total product, we're going to be using labor, one thing that is changing, right? So average product is simply the production per labor, total production per labor. So like I was saying, we had that table, right? We had total product here and we had labor there. So here, labor total product, okay, let me just say that labor there. Okay, so we are going to find that we have labor. So one labor is producing 10, two labor is producing 20. So per labor, what are we producing? That is what we are calling average product. So we can just divide this by that, and that is our average product. Okay, what is our marginal product? Our marginal product is simply what we are producing. So this is just an extra. This is simply an extra output that we're going to produce from the extra inputs that we can add there, which is what? Labor again. So we're going to say that change in total product over change in labor, that is what we're going to call marginal product. Of course, we're just the change. What we mean is that what are we adding to the production that we've already produced? If we add one more unit of our production and one more labor from that to the same production, what are we producing? That is what we're calling marginal product. So we can have, let's say, labor there, capital there, total product there. We have 1, 2, 3. Let's say this one is not changing, just have 1, 1, 1. Okay, let me just say we have 3, 3, 3. So if we're using 1, then produce 5. We're using 2, we produce 10. We're using 3, we produce 15. So our marginal product is we're going to say change in this. So this we have 0 on top there. So 0 minus 5, it is 5. So our marginal product there is going to be 5 divided by, okay, even there we have 0 on top. So 0 minus 1 is 1. So we have that. So this minus that, this divided by that, are going to give the given 5. So our marginal product there is 5. We go to the next one. Again, we subtract this, divide by, this minus that, it's 5 again, just like that. So our marginal product, but it's not, or it's never constant. Okay, it's never constant. This was just my illustration. Okay, otherwise that is marginal product with the formula here. Now, what is diminishing marginal returns? Probably this is a low. This was supposed to be law of diminishing marginal returns. So what is the law of diminishing marginal returns? So this is simply the law of diminishing marginal returns tries to explain how this marginal return, I mean this how this marginal product is going to change when we keep on adding this changing variable to a fixed variable. How is the marginal product going to be changing? So the law of diminishing marginal returns states that the more you're adding a varying input to a fixed input, eventually marginal cost will eventually fall. Okay, it will eventually fall with a with the same if we're going to use the same what do you call it, technology. Of course you're going to find that this is going to fall as we keep on adding the varying input to a fixed input, because you're going to find that as you're adding of course you're adding labor to capital that is fixed. You're going to find that you reach a point where labor will match the same fixed input that is there. And then if we add more labor, you find that instead of total product increasing exponentially, it will start increasing at a decreasing rate. Okay, so if we go in the graph, if we try to take this in the graph, you're going to find that there's a point that we call point of inflation that tries to explain how or where we tend to just stop growing exponentially. Okay, let me just put it like that. We tend to, if our total product is increasing like that, you're going to find that there will be a point of inflation that is there. Starting from here, the more you're adding labor to a fixed uh, input, total product will be increasing exponentially. The more the point once you reach the point of inflation, you're going to find that marginal product, I mean total product, will stop increasing exponentially to start increasing at a decreasing rate. And for that reason, of course, this does not decrease. It can only decrease once it reaches its maximum at zero there. The more you increase, you find that it will start decreasing now. But otherwise, that is how it happened. Or I mean, that is how it happens. Okay. Yeah. So that is about that. And yeah. Okay, let me try to also talk about this. If you look at this table, they are saying that consider the table below and answer the questions that follow. So this table, we have number of inputs that are varying. We have 1, 2, to 10. We have total product. Of course, we have total product 4, 14, just like that. Average product and marginal product. Here we've been given the fixed inputs, but of course we have to know that we have those, probably because we do not know if this is in the this is in the by the way, this is in the short run. Okay, so to find average product, we're going to use that formula that we said. Average product is going to be total product, we divide it by the labor that we have. So we just say this is our total product, this is our labor, this is our labor, because it's changing. So we know that in the short run labor is changing, so this is our labor. We divide by that, we get our answer there. 14 divided by 2, we get 7. 2.5.3, we get we divide by that, I mean 5, we divide, and we get us just like that. We're going to find answers by just dividing this by that, by that, and get our answers there. Okay, and then how do we find marginal product? Again, we used our formula. We say marginal product is simply the change in total product over change in labor. Okay, so change in this, how do we find the change? Here we have the change. If we have 1 there, we are going to assume that we have 0 on top there. We're going to assume that we have 0, and here we have 0. So for us to find changes there, we're going to say 1 divided by 0, it will, I mean 1 minus 0, it will give us 1. And then there's 4 minus 0, it will give us 4. So if we say 4 divided by 1, it will give us what? 4. So we have 4 there. as you can see here, the changes we're going to, it's not all the time that we're going to find the changes here to be 1 1 1. No, like I always mention. But as you can see, the pattern that is here, we have 1 1 1 as the change in labor. So we can just be finding the change there, and we assume to say we've divided by 1, and that is our answer as the total product. So if we divide, we subtract 14 minus 4, it will give us 10. So 10 is going to be our next number. And 25.5 divided by, subtract by 14 to give us an answer. That's like that until we end at the last part. Those are the answers that we have to put in that table. That's how we fill it. Question A was asking us to find the average product. Of course, this is just the same thing that we're just from solving from the table, together with marginal product. It's the same thing that we're just from solving from the table. And then B is saying, with the aid of a diagram, illustrate the relationship between total product and marginal product and average product. So here the relationship that you can illustrate is the relationship between total product and marginal product, and the relationship between average product and marginal product. You cannot illustrate average product with total product with average product. No. Okay, so this is marginal product is the one that you can illustrate with these two. So using the graph like I've asked, we can try to put it here. Let me just try to put it there. We say we have a graph like that. Let me just do that. So if we have our total product is increasing like that, and we have this point of inflation, which is the maximum point of the average, the marginal product. So we are going to have something like that, which is here, like there. Of course, I'm just drawing this, but this is supposed to be the maximum. Okay, so we have average product there. Okay, it is supposed to be tangent to that part, so it's supposed to be tangent somewhere there. Like I've said, I'm just drawing this. It's just I don't have a straight board, so you should draw it properly when it comes to drawing it if a question was to come like that. So that is that we have that as the maximum. So this is the average product of labor, and that is our marginal product of labor, and this is our total product, this graph. So our total product is going to be 0 at the point where maximum at the point where marginal product is equals to 0. Okay, so now illustrating we can put total product there, 0 there, and 0 there. These two graphs are not supposed to be together, but this one's supposed to be on its own, and that one's supposed to be on its own. Just do it like that because I do not have space. Okay, I hope that is clear. So the relationship between total product and marginal product of labor is that when marginal product of labor is increasing, okay, when marginal product of labor is increasing, like from this point until the point of inflation, total product increases exponentially. Okay, to be increasing exponentially, we produce 2, 10, 50, just like that. That is exponential change. Then the moment marginal product reaches its maximum here at the point of inflation, it starts to decrease, right? It will start to decrease. Total product will start to increase, but at a decreasing rate. As we were here, it was increasing at an increasing rate exponentially, and then once we move from here to there, it will start increasing, but at an decreasing rate. Okay, then if marginal product of labor reaches 0, then it means that we've reached the maximum of the total product of labor. So once this reaches 0, which is this point, right, you find that total product, that's when it becomes maximum. If you produce more here, you find that now you start getting negative returns to your production, so you don't have to exceed that point. Okay, don't have to exceed that point. Okay, now we can also talk about the relationship between average product and marginal product of labor. So as you can see, if marginal product is increasing, marginal product of labor is increasing, even average product of labor increases. It will be increasing. The moment these two intercept, it means that this marginal product is, I mean, average product is on its maximum. That's why they meet or intersect with the marginal product of labor. Okay, that is how it works. And then once marginal product of labor starts to decrease, of course it was decreasing from here, right? But once they exceed that maximum point, it starts to decrease further. It will mean that even this will be dragged down, it will start going up. Marginal pulls the averages up, and it can also pull it down when it is going down. Okay, so that is how we illustrate the relationship that is there. Okay, like I mentioned, I was trying to be a bit fast so that everyone should at least just get something from this video and try to solve some questions that they can manage to solve from out there. Okay, so question C was saying show the stages of production in the diagram in part B. So of course, remember that this same graph that we have here, the stages were three stages. We have decreasing the tens, we have increasing the tens to increasing the tens, we have diminishing the tens to scale, we also have negative the tens. So as we are increasing at first here, so it's everywhere here. As we are increasing at this part, that's why I was cutting, like I put these lines that are here. So all this part, let me even change the color. All this part, this part, this yellow part. So that yellow part is what we're calling increasing returns. So at this point, you find that the firm is the returns are coming out exponentially, so they are called increasing returns. Let me also change the color there. And then starting from this point to there, all this part, it is going to be called diminishing returns. So here, diminishing returns is the normal one. So you find that diminishing returns here, the firm is, of course, total product is increasing, but it is increasing at a decreasing rate, because it's not all the time that a firm is going to be producing whatever quantity that is producing exponentially. Okay, it's not always like that. Normally in real life, this is never the case that a firm is going to be producing on this part for increasing returns. The normal part is decreasing, diminishing marginal returns. And then lastly, I think I'll put this part in the blue part. So this part, this is called negative returns. So negative returns are going to be coming out after this firm produces more than it is supposed to produce. It reaches its maximum, but it continues to produce. It will now start making losses even when it is not supposed to be making losses. So at this point, the firm is not even supposed to be producing here. So it is, this point is irrational, this point is considered rational, and this last point is considered to be irrational. Okay, so I'll cut the video now. Subscribe to the channel and like, also share the video. Try to comment on what you didn't understand so that we understand what we're supposed to go through together. Okay, I'll create another video on the next part. For now, thank you for watching.